For every force, there's an equal but opposite reaction force. Good. Anyone have a different way of saying it? Or are there things that she'd be missing? Yeah, what do you think? Yeah, for every action, there's an equal and opposite reaction. Anyone have different words, different way of saying it, or different pieces that these are missing? There's one thing I would add, and that is it is the same kind of force. Is it possible to exert a friction force with one hand and a tension force with the other hand? Is it possible for the Earth to gravitate us down and us to feel and us to cause a countering force by frictioning the Earth? Does this equal and opposite my gravity? Can you tie a rope to something and pull it and have the reaction force be a gravitational pull? No. So muy importante is that the third law of pairs are always the same kind of force. Hey, how many objects are interacting with the third law? Give me the finger. 1, 2, 3. Fuck you. What? Show many. You can vote more than one time. Yeah, 2 objects interacting. 2 objects interacting. Yeah. So muy importante. How many diagrams do you need to draw the action and reaction pairs? 2. I say left axon right, right axon left. There are 2 bodies that are interacting. 2 hands are interacting. So you draw 1 diagram for left hand, 1 diagram for right hand, and if you wish, a 3rd diagram for jazz hands. Okay, silliness aside. Let's do some, what am I doing? Let's do some physics. Question uno. Oh, right, yes, and I've been telling people stuff, lecturing about this stuff, and no clicky. In particular, several of the Newton's third law questions that more than half of the class goofed on in the 3 o'clock section. Some of these questions are things we've covered 3 times now. If you're in my lab, 4 times now, and they're still getting it wrong. So instead of telling you and hoping that you remember, I'm going to guide you through Socratically. This requires that you engage more. I'm not going to tell you things. I'm going to lead you to discover things. You still need to write down and take notes on what you learn and why you learn it, yeah? You can't just do a Socratic learning session and just like let it wash over you. Well, you can, but you get no benefit and you will fail the final midterm. Okay, here we go. We're doing the person and cabinet problem. And I want to focus on the cabinet. Person is, again, here's the setup. Here's the background. Person shoves a cabinet, is exerting a force on a cabinet, pushing a cabinet to the right. They're getting tired and the cabinet is slowing down. They must be slowing down too, yeah? Deja vu? There's friction between the cabinet and the floor. Tell me, B, Google form B, what force acts to the right on the cabinet? What force, C, acts to the left on cabinet? D, which of these forces is bigger? So take out your Google form. Question A is your name. Do you hit submit at the end of the day or during? During. And then do you hit edit response or submit new? Good. No, edit. Otherwise, I have your name 5 times in my thing and it's annoying to look at. Not your name. Your name is beautiful. The spreadsheet is annoying to look at. Anyway, you know what to do. Get to this. Ready, set, go. The cabinet is touching the ground. I'm just a bad artist. Let's review again for B and C. How do I label forces? So that I can grade this efficiently, typing out a long form description is a little bit difficult for me. Please, 3 letters for B, Three letters for C. What's the first letter? Type of force. What's the second letter? Cause. What is exerting? What is the third letter? What is feeling the force? Again, because only like 3 people responded to that. First letter in the triplet notation. What kind of force? Second letter. What causes the force? Third letter. What feels the force? Now I give you time to do BCD. Sliding right, slowing down. Sliding right, slowing down. Yep. Okay, I got 60 responses. There are about 80 people here-ish. Please turn to your neighbor when you are done and show them your results and ask them the following. Did I write in the triplet notation? The triplet notation involves 3 letters. The first letter is, the second letter is, third letter is. Talk to people around you and see if at least one person knows what was just said, yeah? Rude. All righty, time's up. For B, we're at about 60%. I would like this to be 100%. Let's talk about the nature of the forces, because that seems to be the biggest goof. There are plenty of people who know what's causing the rightward force, but we're goofing up on the kind of force. What have we ever talked about here? Tension, weight, normal, our new boy, friction. Yeah? Is there anything else? Am I forgetting one? Tension, normal, weight, friction? Right? Okay. What's a characteristic of tension? Is there a rope? Is there a rope? No tension for you. What's a characteristic of weight force? Planetary exerted. Is the planet pushing the sucker right? Not a weight force. So now we're down to friction and normal. Which way is normal? Always. No, ha ha. Very common goof. Normal is often up, but not always. Thank you for being the one person who responded, though. Yeah? You get brownie points. Man, I want actual brownies. Thanks a lot. I'll bake you actual brownies, but then I'll eat them all on the way here. Anyway, moving along. Normal force is at right angles to surface. So if the surface is vertical, which direction is normal force? If the surface is like this, which direction is at right angles to this surface? Yeah. If you're talking about the normal force that a floor exerts, which direction is normal? Yeah, yeah. Now, there's very often a floor in these physics problems, which is why so many people think that normal is always up. Girlfriend. Normal force is perpendicular to surface. If I push down, normal force be up. If I push up, normal force on me is down. If I push sideways, normal force is sideways. Normal force on my hand is leftward, and towards your right. Okay, so friction, which direction would friction be? If our surface is vertical, which direction would friction be? On the sidewall. Friction would be either in or out or up or down, right? That is along the direction of surface of the cabinet that you're pushing on. Very many people told me that the force pushing rightward on the cabinet is indeed the person pushing on the cabinet. The nature of this force is not tension, not weight, not friction. It's normal. Turn to your neighbor and express, how do you know it's normal? Both why it's not, the other things, and why it is normal. Absolutely. Normal force is any time two solid objects don't want to occupy the same space, and the direction of that force is directly preventing them from directly facing through each other. Frictiony is along surface, normal is through surface. Oh, you can have a friction from your hand against the cabinet. For instance, push at an angle, and part of my force is friction, pushing downward on my hand. Or push downward like that, part of it is friction. You're absolutely right. The floor is totally going to exert a friction force on the cabinet too. Okay, usually when you turn to your neighbor and discuss, that reveals a question. Somebody give me a question. Questions for the question god, skulls for the skull throne. No? No one has a question for the question god? How about a skull for the skull throne? Anyone have that? No one knows that reference? One person knows that reference. Question, yeah, yeah. NPC, baby. That's right. NPC is what I was looking for. It's a normal force because solid, not phasey through at right angles to the interface. What causes the rightward force? Come on, what's pushing right? P. What is feeling at C? not NCP, rightward force on the cabinet is felt by the cabinet. Watch out for that. That was only a couple people. Okay, now what pushes left? What opposes the motion? Turn to your neighbor. No, well, almost everyone got this. F, friction. Friction opposes the motion. I mean, if it weren't for friction, would this cabinet slow down? You butter the floor. Is the cabinet gonna have any opposition to movement? No. I mean, that's, by the way, that's a reasonable check. You can imagine this. Suppose you butter one surface and cover the other with olive oil. Is there still a force? Well, if so, it's probably not friction. Yeah? Imagine this. Icy road and your tires are all smooth. Are you going anywhere if you gun it? So tires on road, that's a friction interaction. Yeah? Okay. The leftward force, what slows it down? Is that a friction interaction? You betcha. You betcha, don't you know? If you iced and buttered and olive oiled the surface, that cabinet would have nothing to keep it from zooming off to infinity and beyond. So this is a friction force. Of what? What causes the friction force? Not the person. Please note, the person is pushing to the right. Does it also make sense that they are exerting a leftward force too? A bunch of people told me that the person is also exerting a leftward force. No, 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 no. First exerts a force in the rightward direction. They're not also frictioning to the left. Now, what are the subscript? What causes that friction? What letter? I didn't tell you. So you should make one up. G, F, E, ground, floor, earth are all reasonable things to say. Although for what it's worth, I usually reserve earth for when I'm talking about the planet as a whole, and ground or floor or rug or whatever for what's immediately underneath your feet. Okay, so what I was looking for 2 is FCP or something like that. Friction of carpet. No, 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 no. CP would be the cabinet on the person. I should be saying FGC is what I was looking for. Friction force exerted by the ground on le cabinet. What does Newton's second law say? Acceleration is proportional to which force? The net force. Is this cabinet accelerating? Any change to your velocity vector is an acceleration. Slowing and speeding are both accelerations. Remember, if your velocity vector isn't constant, if your velocity graph is not constant, if you got a slope to your velocity, this guy's slowing down, moving rightward, positive velocities, and slowing down, sloping down towards zero. Okay, so, is he accelerating? Yes. Does he have a net force? Thumbs up or down? Does he have a net force? Yes or no? Yeah? Okay. Can the forces be balanced on this sucker? Yes or no? What do you think? Are the forces balanced on something that is accelerating? Ever, ever, ever. Never is the correct answer. Half of you told me they're equal. So as I described verbally, maybe I should have written it, we are moving to the right and getting tired and slowing. Now, if the cabinet's just staying there, just exerting a force equal to the static friction force, nothing, right? Maybe that's what y'all were thinking. Okay, so follow-up question. Next question. E. Hopefully, this is EZ. True or false? Yes or no? And hold on a second. Hold on a second. Please do this individually. In my lab section, about half of y'all were still goofing on this. I want to see each and every person if this is clicked yet, or if you're still struggling. So don't talk until both of the people who are involved in the talking interaction. In other words, don't talk to your partner until you're both done. That's what I'm trying to say. Are these third law pairs? Are these action-reaction pairs? Yo. Friction. Okay. So, follow up. I'm not going to tell you the answer yet. Nah, screw F. Skip F, skip F, skip F. No, skip G. Hold on a second. Hold on a second. Sorry. I thought I asked different follow-up questions. Someone out loud, what if Newton's third law says action-reaction pairs are what? Equal and opposite of the same kind, yeah? Are these the same kind? Are they equal? How do you know they're not equal? They're not the same kind of force and we're accelerating. Please reflect on your answer to B, and change your answer if that is internally logically inconsistent with what we done just said. Y'all are still doing better than the 3 o'clock class, in which about a third of them got this wrong at first. But I'd like 100% of both sections. S'il vous plaît. I get this. Okay, I still have not convinced a good 10%. Question first. Friction. I mean, if he's slowing down, moving right and slowing down, the friction is winning. Okay. And again, reasoning here, reasoning. The two forces are different kinds of forces. The two forces we reasoned through because you're accelerating are not equal forces. Can these be the equal and opposite forces we just discussed? No, these are not third law pairs. Question F, identify, triplet notation, no essays, please. Triplet notation, identify NPC's third law pair. What is the third law pair to the force that the person exerts on the cabinet? Question F. I guided you through. The answer is no. Sorry? Answer. Yeah, well, that's what I'm saying. On F, answer the second part of this. You now know the answer is no, or I hope you know the answer is no. So the second part, yeah, tell me the third law pair. Hey, we've still got 5 people who aren't showing answers. 1, you're asleep, or 2, you're not hitting submit every time. Wake up, or both. Hit submit every time, please. Let me see what you're getting. Remember also, if you are shy from being confuzzled, you don't have to get it right, but you do have to try. Oh, so much better. So much better. Oh, that's better than any drug. What a hit. Good. The third law of pair to the normal force of the person, zero it's on the cabinet, is the fact that the cabinet pushes back on the person. If you're goofing on this, please write this down. Here's how to find the third law of pair. Uno, it's always the same kind of force. That's what I said at the beginning of class, right? It's always the same kind of force, always the same kind of force, always the same kind of force. Write this down if you got it wrong. Dos, part 2, is it's always the same pair of objects. If the person pushed on the cabinet pushed on the person. Notice that ground did not appear in there. If the friction force between the ground and the cabinet is your action, then the friction force between the person and the ground cannot be your third law pair. Cabinet, ground, ground, cabinet. Okay. Is good? Oh, wait, what's step 3? Anyone know step 3? There is no step 3. It's 2 things to remember. Same kind, same pairs, just opposite order. G. What is the action-reaction pair? Oh, you can't see that. What is the action-reaction pair to the weight force that Earth exerts on the cabinet? As Dr. Faustus said in Marlowe's famous play, all up to my God who pulls me down. What is the third law pair to that? No literature students in here? You guys are pre-meds, of course, no literature students. Okay, never mind. Oh my sweet baby Jesus, so many right answers. Hold on, give your classmates a second to respond, s'il vous plaît. At least, uh, uh, babble quietly. Okay, time's up. Put your best shot. You got 90% responding. I would like to move on. Turn to your neighbor and discuss. You should double check to make sure that both you and your neighbor satisfy both criteria. Is it the same kind of force? Is it the same pair of objects? Check each other. Check yourself before you wreck yourself, please. And the correct answer is the weight force that the cabinet pulls up on the Earth with. If the Earth pulls down on the cabinet, what kind of force? So the pair is weight. If the Earth pulled on the cabinet to exert that force, the cabinet pulls on the Earth. The normal force has nothing to do with it. Here's how I prove the normal force has nothing to do with it. Drop the cabinet off of a tall building. One, you're going to jail for reckless endangerment. But two, before that happens, you will realize that the normal force has vanished, right? There's only one force on the cabinet if he's freely falling through the air. Did you just break the third law? You broke a law, but you can't break the third law. Okay. Question oh, to H with it. Okay, I apparently can't spell. No, my alphabet. Whatever, skip H. If the cabinet weighs 500 newtons, tell me about this third law pair. I said that the Earth pulls up on, the cabinet pulls up on the Earth. Compare the forces. Which one is bigger? Or are they equal? How hard is the Earth pulled? I'm sorry, I. Yeah, same situation. Same situation. Yeah, skip H. Skip H. Skip H, skip H, skip H. In I, tell me the Earth pulls down 500 newtons. How hard does the cabinet gravitate the Earth? More or less or equal to 500? Which magnitude is greater? I did not define a coordinate system with directionality, so I'm talking magnitudes. I'm talking about magnitudes. Tell me the magnitude of the forces. Which pulls harder? That's a magnitude. Okay, can someone tell me about the third law again? What does the third law guarantee about the intensity of the pushes or pulls? If you got this wrong, please write this down on your forehead where you can see it when you comb your hair in the morning. Newton's third law guarantees the forces are equal. If the Earth pulls with 500 newtons, the Earth is pulled by 500 newtons. Watch for this. If you catch this, Newton's first and third law questions are gimmies. Please note, we've been doing this for what, 3 weeks now, and I taught you the third law on the second day, I think. If this is not clicking with me explaining, YouTube has some good videos. No, I don't have a favorite, but I encourage you. Or the book has some words of wisdom. Let me encourage you, seek out what you need. We're getting closer to 100%, but we're done with the conceptual the conceptual push here with the third law. I'm gonna, if you're still, you have to seek out the knowledge on your own at some point. And we're at 90%, so I'm gonna say we're close enough. The correct answer is equal to, equal to, equal to. Hey, follow-up, what causes tides? The moon. The moon's pull on the Earth. Does the moon just pull on the water, or does the moon pull on the Earth as well? Does the moon exert a force on the Earth? Does the moon exert a force on the Earth? Does the Earth exert a force on the moon? Which is bigger? Which pulls harder? Neither. It's equal. Newton's third law. Good. Okay, so all weight forces are equal, right? Hey, follow-up question, Question blah, 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 blah. J, I said this is the last conceptual question, it's not. Which exerts a bigger weight force on the Earth? Which is the weight bigger for, the moon or the cabinet? Question J, which exerts a bigger weight force? Or are they equal? We just reasoned through that weights are equal. Does that mean that all weights are equal? Again, the question is, based on our reasoning that we've got, which exerts the bigger force on the Earth? Which exerts the bigger weight force on the Earth? Or are they equal? Which object has a bigger weight force on the Earth? Okay, follow-up question. I'm going to call time's up. Two follow-up questions, and I want you to discuss with each other here. What causes tides again? Do cabinets cause tides? But I thought I said the weights are equal. Discuss with your neighbor. Is the weight of the Earth equal to the weight of the... Are these weights equal? If so, why or why not? Keep in mind, the cabinets, last I checked, do not gravitationally pull the Earth enough, the water enough to make a tide. The moon is not Earth? Actually, the moon is a fabrication by NASA. It's all a big lie. It's not just the moon landing. The moon itself doesn't exist. And the Earth is flat. And vaccines put chips in your body. And give me autism. Yep. That's the way it works. And F equals mv. Oh, that even tasted worse than saying the Earth is flat. Hey, does anyone have a refutation for the hypothesis that all weights are equal? I mean, if I stand on a scale, I weigh 140 pounds. If I step on a scale, I weigh 140 pounds. Isn't that my weight? No, pounds are actually weight. If I step on a scale and it says 700 newtons, is that my weight? Isn't that my weight? Isn't that a property of me? No. My weight is not a property of me. What is it a property of? My relationship with the Earth. Very good. Weight is not a property of oneself. What is the property of oneself that I'm... Mass is a property of you. If I go to the moon, what changes? Only if I throw up on the rocket. Your mass is a measure of how much of you there is. Your weight is a property of how hard you are pulled. So your weight can change. At noon, I weigh less. I push less on the scale. Do you know why? Sun pulls me up. It's a very small effect. Actually, hold on. I lied so hard, and this is exactly the distinction I'm trying to convey here. I'm sorry. Can I take back the last minute? At noon, my scale registers a little less. Why? I have two weights. I have two weights. The earth pulls me down, the sun pulls me up. It's a very, very small effect, but theoretically it's there. The sun gravitates me towards it at noon. My scale registered a different thing. Hey, by the way, what's a scale measure? You know this? Good. Here's how to tell that it's normal force. Does my scale say the same thing? Does my scale say the same thing if my wife puts her toe on the scale? Oh, that rascal. No. Scales only measure how hard you push on them. Scales can't measure your weight. The only thing that could feel your weight is the earth. Okay, so what's the takeaway for here? Are all weights equal? Is weight U the weight of the earth? Is that a thing? You have to say the weight of the earth compared to what? The weight on the earth force. There are gravitational interactions. The moon pushes or pulls on the earth, pulls on the earth. The cabinet pulls on the earth. The third law pairs to these are what? What's the third law pair to the fact that the moon pulls the earth? The earth pulls the moon. What's the third law pair to the fact that the cabinet is pulled by the earth? The earth pulls the cabinet pulls the earth. Okay, I am not saying that the moon and the cabinet exert equal weight forces on the earth. I'm saying that the cabinet pulls the earth equal to the earth on the cabinet. The moon pulls the earth equal to the earth on the moon. Hmm? Hmm? Okay, let's do, no. Turn to your neighbor and discuss. What's the whole point of the last 45 minutes? What's the idea? And how can you avoid getting tricked by this on the midterm in 2 weeks? What's the big idea? Okay, I think that's enough time. Who's still having an important discussion? Okay. So, this concludes this part of the Newton's third law emphasis. Really want 100% of y'all to get this. As I said, what's this clicks? These questions are gimmies, baby. These questions are gimmies. And this is required for you to get anything right that involves more than one object. You have a free body diagram, you have two objects or more interacting, you gotta have this to get this right. Please seek this out. There's more than one resource. Hell, my office hours today only had one person. Make use of me. Don't just wait for physics to occur to you. You gotta work for it, okay? Now let's do a numerical problem. I'm going to give you some extra information, more information than you need. And I'm going to ask you as follows. No, I completely biffed up what numerical values are, but I want it to work out to something vaguely reasonable. So a 10 kilogram, that's only a 20-pound cart. I don't know, shut up. A 10 kilo van is driving at 20 meters per second. Then they merge into another lane, and within 10 seconds, they're driving at 25 meters a second. Something like that, okay? Gets on the freeway from a frontage road, speeds up. It's got a really bad engine. It takes 10 whole seconds to speed up by 5 meters per second. The back of the van has two boxes, a 3 kilo box and a 5 kilo box in it. Find the coefficient of friction, the static coefficient, such that the boxes don't slip. I strongly encourage you to draw some free body diagrams here. Okay. You're looking for defriction. No. I've said enough. You can work together on this. Totally work together. This is question K, and feel free also to ask for hints. If you think about it clearly, you only need two equations. Yes, you need the static friction formula. And I'm not looking for a force. I'm looking for a coefficient of friction. Tell me mu. Tell me mu. Tell me sweet little mu. In particular, I'm looking for the smallest mu, the mini mu, minimum mu. And you only have three formulas in this module, by the way, plus a single formula for finding acceleration. If you're not sure, talk to a neighbor. But there are only a couple of things I expect you to know at this point. Who's stuck, by the way? Okay. What are the only three formulas that I've taught you this module? Newton's second says F equals ma. Net force equals ma. What's the friction law? Friction force is mu times normal force. And what's the weight formula? Weight equals mg. That's all you need. How do we calculate acceleration, by the way? What is acceleration? Change in velocity divided by time. I don't want a. I want mu. Hence in like 2 more minutes. Keep chugging. A lot of correct answers. Which also means if you're stuck, ask around. Okay, so if you are not done, or if you are not sure of your answer, draw a free body diagram. Draw a force diagram. Hey, of what? What am I asking about? What objects are interacting? What objects are interacting if the boxes don't slip? Earth in the box is a weight interaction. Box in the truck. Which friction am I talking about? There's a friction here. There's a friction here. Point up for the box friction, down for the tire friction. Up for the box friction. Come on, everyone vote. Which friction am I talking about? Up for the friction of the boxes, down for the friction of the truck tires. Okay, there are a lot of ups and a lot of I don't knows. Let me encourage you to reflect on this again. I'm asking for the friction, the stuff about the boxes. Do the tires touch the boxes? So do the tires exert a friction force on the boxes? I don't care about the road. If I ask you about stuff about the boxes, I want to know about forces on the boxes. Consider the boxes diagrams. Is the truck even relevant? Well, you need to know the acceleration of everything, but the truck's forces are irrelevant. So which box do I choose? Actually, it doesn't matter. Ends up canceling out. But pick one. Let's do the 3. Draw a free body diagram for the 3. Label those forces. At least the kind of force. Don't just draw arrows and say F. Okay, let's practice. What's up? What's up? Come on, what force acts up? Normal of truck on the box. NTB. NT3 maybe. I don't know. However you wrote the box. Okay. What's down? Weight of what causes weight? Earth on box. So I'd say WE3 or WEB. Okay. What other forces act on the box? Are there any other forces? There better darn well be another force because he accelerated, yeah? If there's no other force, how could it accelerate? There is a friction force of the truck. Which direction does that act? Point. Everyone point. This way or this way? Come on, everybody take a vote. Don't be that way. I thought my generation's supposed to be the apathetic ones. I wish I could give extra credit for actually voting, but come on, point the way. So, does the friction force act that way or that way? Oh, we are split down the middle. How many forces act horizontally? Show me. 1, 2, 3. How many forces act horizontally? Oh, we're split on that. How many objects interact with the 3-kilogram box? 2. What are they? Earth, gravitational force, and truck. Can the truck push both left and right? No. Friction either acts left or acts right, and that's the only force acting in the horizontal direction. Yeah, does that make sense? Okay. Now, the truck is accelerating that way. Which way must friction be? If the only horizontal force is friction, if the truck is accelerating that way, friction is pushing this way. Net force is this way. Net force is friction. No, absolutely not. Absolutely not. Net force just means all the forces. In this case, there's only one force acting in each direction. In the horizontal direction, there's only one force acting. It's friction. What about the vertical direction? What would net force be? 0. And what would go into that? What are the recipe ingredients that make up 0? What would you write down if you wrote sigma F equals? Normal and weight? I don't know what and means mathematically. Plus, times, minus, divided by, to the power. How do we combine forces when I ask you for a total? Add considering direction. Weight go down, normal go up. Yeah? Weight minus normal equals ma, and the vertical direction equals 0. Weight minus normal equals 0. Hey, by the way, how much does it weigh? Ish. 30 newtons, how do you do that? mg, and for the sake of not having a calculator on me, I'm going to say g equals 10. So this sucker weighs 30 newtons. What's its normal force? That's only a couple people answering. What's its normal force? 30 newtons. How do you know it's 30 newtons? Is normal always weight? No, he's not accelerating in the vertical direction. He's in vertical balance, Newton's first law situation, yeah? Okay, so which direction is friction push again? F equals ma. What's his net force? What's m? 3. What's a? And in this case, acceleration is 0.5. How'd you get that, by the way? How do you get a as 0.5? So I've been saying too many things. I should never say math. I'm sorry if you have gotten lost from all the words. And which force am I talking about, by the way? Horizontal or vertical here? You might even write subscripts to remind yourself if I'm talking about ma, which way is the accelerating rightward? So what's his net force? Now what's the punchline of Newton's law? F equals ma. What's F? What's the normal again? Not 3. Should I say 3 or 30? 30. Solve solve. Balls. Okay, now there be like 10 steps in here, 10 places for you to goof. Turn to your neighbor and please intellectually step through each step by step. What did Tucker do? Why did he do it? What's the physics behind it? Yeah? You do? Where's that go? And then I want questions. I'm the God of questions and I demand questions as my prayers, okay? I'm going to plug in n. So mu times 30 equals, don't be confuzzled here. Don't be confuzzled here. That's, if I write a number with a letter after it like that, I meant the unit is the Newton. This n is Newton, this n is normal. Very important. Okay, now about 60% of the class got this. I am pleased. This involves using the weight force formula, the friction formula, and Newton's second law. Good, good. It's a moderate complexity. I want you guys to all get this by midterm. Ask me a question. Where are you getting confused? What is still hard? What is easy? What is hard? X is horizontal. Y is vertical. Yeah. What'd you do? Has to be. Has to be. Has to be. Because the box and the truck, normal and stuff, tells me about the ground on the wheels. Doesn't tell me about the box on the. Also, I think you must have goofed. Did you include the fact that the boxes pull backwards on the truck? Boxes pull backward on the truck. You need more friction between the truck and the ground. That's actually the next step, is to draw that diagram. The direction of friction on the boxes, if there's only one force acting on the boxes, Newton's second law says acceleration is always in the direction of net force. There's only one force that is the net. The truck is accelerating to the right, not just moving, accelerating. Friction is not always opposite the direction of motion. Looky, here's the example that I gave before. Here, I'll just do it with the whole thing. I'm going to line this up with the edge of the table. If friction opposes the direction of motion when I pull this, then it should recoil, right? Which way did it move? Why did it move that way? Why? How do you know why? Not just, well, of course it goes that way because they accelerate together. Think about the relative motion. Shoop, shoop. It's not just that the bag goes to your right. It's the bag, the bag is slipping to the right, the notebook is slipping to the left. Friction opposes that relative. So bag over, notebook over bag, if the notebook is slipping leftward, friction opposes that relative slip and tries to exert a rightward force. Incidentally, the bag feeling pulled backwards means the bag is moving to the right. Relative to this, it gets pulled to the left. The bag experiences a backward force by Newton's third law. But the way I would suggest to think about this, the first way to think about this is there's only one thing interacting with the boxes. And if they're not moving relative to the truck, if they're not slipping backwards with respect to the truck, there has to be a rightward force to accelerate them. The only force available is friction. Please ask them both. What's the net force if you've got a 3 kilo box, 3 kilo box accelerating at 0.5 meters per second squared? F equals ma. So 1.5 is m times a. No, you don't like that. What's the mass? What's the acceleration? Do you know why the acceleration is 0.5? Good. Okay. So mass times acceleration is 1.5, 3 times 0.5. Where's the 30 come from? Yeah, exactly. How do you know normal is 30? Good. Solve for mu. 1.5 equals mu times 30, 1.5 30ths. You see? I said, I described so that it just doesn't slip. I didn't say that, did I? I just said don't slip. What you should say is greater than or equal to, I guess, based on what I wrote. What I meant to say is find the minimum mu. Okay, next time we do truck. Yeah. Okay, we're out of time. Adios, everyone.